As it says, my name's Ian Mackenzie. I've been involved in radio and television broadcasting now for more years than I want to know about. I started out in about 1965 working for 2GB in Sydney. And I was in the engineering department, and it was a very, very different sort of place to what a radio station is these days. It was up in Phillip Street, and where I got assigned to initially was up in the recording department. And the recording department used 1/4-inch tape for distribution of most of the programs out to the country stations. They had physical landlines going out north, south and west, so a lot of programming like the news that went out live on those, but there was no satellites and any of the things that are used commonly these days. So the recording, if it was for a lot of the stations, was done on a disc, on a sometimes 12-inch LPs, sometimes 17-inch transcription discs. So I used to cut those. Interesting process. Anyway, I went from 2GB, I was offered a job by AWA in their installation department, so I went there, which was broadcast and TV installation. I worked there for several years, and then moved to Channel 7 and worked in outside broadcasts and links, microwave links with Channel 7. Then eventually moved to a consulting engineering firm. We put in all the mining town TV stations, the low power stations in places like Dampier and Karratha and Tom Price and so on, so they could have television. And the way that was accomplished was a low power transmitter in the town and tapes that were recorded in the ABC that were flown to the town. So, and they ran a week behind, so if you look, well, the thing was, if you got the, say, the Perth newspaper and had a look and it said that Four Corners was on at 7 o'clock on Tuesday night, it was, but it was last week's one. So we did that. That was all on 1-inch tape, and there were 2 recorders, and you.
So how many hours a day did they transmit?
4 or 5, just the evenings. But it was on 1-inch tape, and so you had to do changes. They only went for an hour on each tape, or 90 minutes, so you had to do synchronised changes between the tapes, so that was all good fun. So I put in several of those stations. I did the design of most of them, and then I think there were 7 stations in all, ranging from Weipa across to Groote Island to Coolan Island over in the west.
What year
and then,
was that,
oh, cripes. Of the order of, it'd be 1970, 72 perhaps. But anyway, I wound up from there. I went to work for Channel 10 for a few months and then went to Channel 9, which was a much nicer place, and put in what they called a relay room, which was responsible for everything coming into the station and going out of the station on coax and microwave links and things, so I did that. Eventually then went to Videotape Corporation, which were the first colour company in Australia that did commercials and productions for TV. I went down to Melbourne as chief engineer and then came back to Sydney, and then myself and a few other guys started up our own production house down in North Sydney. And that went on for several years. We did a number of feature movies for television. We did about 10,000 commercials, mainly retail commercials. And then probably not. They were for TV. King's Men, Case for the Defence. I can't even remember the name of a lot of them. But no, we did those. We had one of the first edit suites and colour OB vans in Australia.
What was the name of the company there, Dan?
Television Production Facilities, TPF. And then after about 6 years, we moved across to North Sydney, and we had then two companies there. One was Editope, and the other one was called Videocopy, and we did all of the duplication and copying of VHS and beta cassettes for most of the major distributors, so that with people like Warner Brothers, RCA, EMI, Little Golden Books, all sorts of things. But we had 1,000 machines physically, and so you had a remote control and you pressed the button and 100 machines started, and they were just in rows of 100 on the thing. And there was about 700 VHS and 300 beta, and then it went even up higher than that in VHS because beta was only a very, very small market. And then I sold out of that after about 1990, 91 or something. And since then I've been working as a consultant, and mainly in the area of satellite and radio transmission and television transmission. I got involved in a lot of things, like when the decision was being made as to whether we would use COFDM or whether it would go ATSC, which was the American system. I was involved very heavily in the testing for that with the Commonwealth Communications Laboratory. And then ever since I've been involved in various ways with digital television and digital radio. And I do a lot of work up in New Guinea and out in the islands as well as around Australia. So that's a capsule history of what I do. DAB is digital audio broadcasting, just as a common all-encompassing name for various different systems. It's not all DAB or DAB plus as a name. They call it DAB plus, and they very much promote DAB plus as the thing with the Commercial Radio Australia, which is the lobby group of all the radio stations. But DAB is a generic thing rather than... So the first tests for DAB, but not DAB plus, for DAB, were in Sydney. They came from Centrepoint Tower, and yeah.
Wasn't there?
Well, that's.
That's okay. Keep going.
The tests that were done were on L-band. So down in Melbourne, they were off a different high point down there, down at Dandenong. And the system, L-band's about approximately 1.5 gigs. And the testing that was done said it didn't work properly. There was no appreciable penetration into buildings because of the high frequency. And there was a limitation in the bandwidth because of the compression methods that were used then, that you could only have about 5 channels on a full mux, which was 1.6 megs. And that was the Musicam was a pre-MPEG, pretty awful compression system. Subsequent to that, it was pulled out and they sold it. The government sold the gear, and that was that. Subsequently, there was an L-band system put in for the 2000 Olympics, and that again used the Eureka system, or DAB, and it was set up with a single frequency network, which we'll talk about later, set up between Parramatta and the Optus building in North Sydney. And so that meant you could drive between the two with no problems, and you never lost anything, even though it was L-band. At that stage there was no way that anyone could have used VHF for it, because the TV stations had said, no, that's ours, you know, for television, we can't have radio there. So it was basically put in so that they could have radio in the Olympics site out at Homebush, which of course is right between the two, so it was ideal for that.
Well, it's just point to point though, I think so.
Sorry?
It's just point to point.
No, it's broadcast. Like, I mean,
Who repeated it?
very few people, it's one of the issues with the thing. Well, very much so. Anyway, DAB was originally introduced in the United Kingdom using what they call Eureka 147. And Eureka 147 was a standard which was a European standard, and it basically, you could use VHF, band 3, so 174 to 240, or you could use L-band. And in the UK they used VHF because they used UHF TV in the UK. So they had a whole lot of channels that they could use in band 3, whereas we didn't here. And due to this limitation of 5 or so services in each system, which they allocated blocks. So if you had a 7 meg TV channel, you could allocate 4 blocks in that, and each one of those was 1.6 megs, so you used about 5.8 and a little bit spare. So they could have lots and lots of stations, whereas we couldn't. So it was again a limitation, and once 405 line had finished, there was no VHF being used at all at that stage in the UK. Now in Australia, the only channel which there was any way that you could use for DAB, not DAB+, was channel 9A. 9A was the channel which was originally used for aircraft DME. It was a system which was designed by AWA and worked on the 205 megs. And it was a 6 meg channel which was between channel 9 and channel 10. So the numbering was a bit strange, having 9A, but it was too narrow to put a TV channel into, but it could be used for radio. And again, the TV station said, oh no, we don't want radio in amongst our thing. What they should do is they should get set-top boxes for television and just run radio channels on them, and we'll put them up on the normal channels. And so anyway, a little bit of coaxing that went on. We did myself and a partner did a presentation that was given to CRA, Commercial Radio Australia, and said, you should be pushing this. This is the way to go if you want digital radio. And the TV stations were at first a little bit against it, until we said, if that happens, you know, what's going to happen to your goings on? Wouldn't you rather have it under your control, or have it that suddenly the government decides to sell off 9A for some other purposes? And they went, oh yeah, good idea, we'll have DAB. So the proposal then was not to use the Musicam encoding system. It was to use AAC, which was a much newer, vastly more efficient coding system. And then AAC HE is even more so, and that's what we use today in DAB. So that means you can get about 20 services in each mux rather than about 5. And so that means there's a hell of a lot of channels. So the next thing was to do some tests. So CRA footed the bill. They put up a vertical antenna on Channel 9's tower down at Willoughby, and running a similar ERP to what the TV did. They used Harris transmitters, 3.5 kilowatt transmitters with antenna gain to give 50 kilowatts ERP. And oh yeah, this was very successful. So they then petitioned the government, and the government said, yes, okay, all looks good. And they allocated effectively 14 megs when analogue TV stopped. So there is Channel 9 and Channel 9A were allocated to digital radio, and that's where we sit at the moment, Australia-wide. Melbourne DAB tests mirrored pretty much what was happening in Sydney. The Broadcast Australia put a system up on Mount Dandenong, and the testing period finished. So then, as part of what the government approved, was 3 ensembles, 2 for commercial stations and 1 for the ABC and SBS. So the design of the systems for ABC, SBS and the commercials were quite different. And it wasn't a common purchase, so the ABC wound up with Harris transmitters, the commercials wound up with Roden Schwartz, all doing the same thing, but a bit different. The muxing to put all the stations together and have them multiplexed on each one, on each ensemble, came from 2 different companies. One was Factum, which was out of Sweden, and the other one came out of the UK, which was called Radioscope. And that's another story, but they're still there, they're still being used. I did the design of the Radioscope system for the ABC and SBS, and was very much involved in the design of the commercial one as well, which was very interesting. That showed the everything working properly, except for the fact that in the city areas, in the CBD, and in a few places like up the peninsula here, the coverage wasn't really as good as it could be. It's the same with television, but there wasn't a repeater like there was at North Head or up at Buddy or places like that, so it was restricted just the single transmission point. So they started looking and saying, well, perhaps we should have repeaters. So the first repeater we built, designed it and built it, and it runs 1 kilowatt, and it runs all 3 ensembles. It was put in at 101 Collins Street down in Melbourne with 14 or 15 degrees down tilt. Takes the signal coming in from Mount Dandenong, and it's a single frequency repeater. So the output frequency is exactly the same. It's synchronous with the input frequency. And there's our isolation plus a whole lot of clevers. So we'll get onto that. So that was put in, and it then had excellent penetration in the CBD down there. So we then went and put another one in Centre Point in Sydney. There's now 5 of them around Sydney, and a 6th one about to go in.
101 Collins Street down at the bottom of the hill, isn't it?
No, it's pretty much at the top end of Collins Street. It's not Rialto.
Sorry, Melbourne and the hill?
No, the one down the bottom is Rialto. Yeah, the one down the bottom is Rialto.
Oh yeah, no, I heard that. Yeah.
But no, it's the Motorola site up in 101. So, okay, what is DAB? It's the transmission of radio broadcasting signals by the new digital methods instead of conventional AM, FM and analogue modulation. So there's different DAB schemes, each with its own advantages and disadvantages. Now we talked a little bit about DAB+, but all of the options, or nearly all of the options, use digital compression. because it's the only way that you can keep the bandwidth down to a reasonable usage of spectrum. Most systems use OFDM, or a form of modulation which is multi-carrier. And it's the same, exactly the same method as we use for digital terrestrial. So when you watch Channel 7 or Channel 9, you're watching an OFDM signal. It's actually a COFDM signal, which means that there are a number of carriers, which can be like down as far as 200, anything up to 7,000 carriers for TV. And the carriers are broken up into a quadrature type. So there's two signals being transmitted at once. And that gives the advantage of being able to put data on one of those carriers, or on a carrier, but the carrier has got, over a period of time, it changes in phase. So that means that the data that you're putting in is the total data for the system, be it 7 megs for TV or be it 1.6 for DAB. The total data is split across all the carriers. And what that means is that it minimises, it's got a lot of forward error correction. And so it means that if you get an ignition pulse or you get something like that, it can destroy a couple of carriers, but it doesn't necessarily break the whole signal up.
Multipath would do the same thing, won't it?
No.
No?
Multipath is good. We want that.
Yeah, but that's what I'm saying. It won't kill the whole band. It'll only kill some carriers.
No, it doesn't kill any carriers.
Multipath will affect them all, but you get around multipath by having a lower symbol rate.
Yeah, but if you get phase remaining cancellation,
Doesn't matter.
Okay.
What happens with multipath or with reflections and things like that, COFDM means that there's a thing called guard interval. And the guard interval, they retransmit some of the data that's in the main frames, and it gives you a situation where as long as it's getting RF, it doesn't really care what the timing is. That's how a single frequency network works. As long as you're on the same frequency, as long as you're symbol for symbol matched, so that the data stream that is on the multiple transmitters is exactly the same. You can't have different information on one transmitter to a different transmitter, so you can't localise a program in a single frequency network. But you can have as many transmitters as you like, and by varying the timing on them, what you can do is there is cancellation, and there are areas where it won't work because it's just too far from the transmitter to the distance to the other one. So unless you have it so that they're not somewhat different or somewhat the same in distance between them, it all works perfectly. Anyway, rather than having 5 services, there's what's on the AMUX in Sydney. And there's about 20 services in there. So a lot of them, like we've got here, 2SM, it's a simulcast of the racing radio, simulcast of Triple M and so on. Some of these others, like Buddha and so on, they're, where are we? They're not all there. Gorilla is another one. Yeah, Gorilla is Zoo and those there. They're all part of Corralis's network, which is the super radio network, which is 2SM and 2HD. And they're all there. Basically, there's no commercials or anything on those. They're just music stations. And they're paid for by 2SM and the 2HD. And his thing is he's got John Laws, so lots of people listen to that, and they do promote On some of those they promote 2SM, but not to an enormous degree. But they're all up on the satellite. He's got 8 channels on the satellite, and that's waiting for the government to authorise regional DAB, which looks like it'll happen in due course. When that happens, he's then got, in actual fact, 6 programs that he can put up in any, if you go to Grafton or you go to Dubbo or anywhere else, he'll have 6 digital services available. Gorilla and, sort of Zoo and all those. At the moment, all they are, they're sitting in a rack. Well, it's actually a program, but it's totally automatic.
Yeah.
The thing just sits in a PC in a rack, or actually there's several PCs in the rack, they're all muxed together and that's it. And they're uplinked out of 2SM down at Piermont, and they're available anywhere. And just a matter of interest, they're actually not scrambled either, so you can listen to them off the satellite if you've got an appropriate receiver. So, but that meant you can have about 60 services in Sydney between the 3 muxes in Sydney, which is, it opened up like it did in the UK. They wound up with over 120 stations in London. So it's suddenly, from being one station that took 10 kilohertz, you're now talking hundreds of stations if you want them.
But looking at the bit rate, it's interesting how a lot of them got different bit rates. So
yeah, well, that's deliberately done.
Different qualities, and you'd imagine the ones with the higher bit rate would have the better quality, with the ones with the lower bit rate, like
look,
32 kilobits.
32 kilobits is because it's people
just
calling races. In actual fact, they did that because they pump out. That's a little misleading with the 32 kilobits because they're also pumping out a lot of data. And the data is all the betting odds and things like that and it goes out to the TABs.
And that's included in the 32, isn't it? Or is that
no, they've got
additional 32?
Every station got 256 kilobits, and they could break that up any way that they wanted. So when the main stations, which are basically the normal ones, there's 8 normal stations and 8 FM stations in Sydney, so there's 16 stations. The allocation of bandwidth that they weren't using, they put up for auction. And so various other people, like for instance Triple M and Southern Cross and so on, bought more bandwidth so they could run more bandwidth on their services, but they had to go and buy extra bandwidth over and above the 256. So,
but it's interesting looking at that to see these so-called simulcasts, they call it simulcast on the FM station, you've got the higher bit rates, so when you do the A to B comparison, your FM to this, it sounds okay, but where they don't simulcast, the music ones, you've got lower bit rates, so sort of seems a bit cheating, doesn't it? Lesser quality when you can't do the A to B comparison.
Well,
is that just being too conspiratorial?
I think you've been a bit conspiratorial there.
It's an amazing coincidence, isn't it? What?
He's just one step this side of being a prepper.
Look, you get somewhere like classical music is 102.5, which is basically 2 MBS. So they're running a reasonable, I mean, believe me, AAC plus HE is a hell of a lot better than the old music cam, but it's also, you'd be hard pressed to tell the difference between it and FM. Those ones that are coming down 32 kilobits and so on is deliberately done where they don't need that. You don't need it. The same as on television, if you look at the bit rates, like Channel 7's running 7 programs, 6 or 7 programs in their 7 megs. One of those is HD. They've gone to using H.264, which is the equivalent sort of thing with video compression. And you can get HD quite happily at about 4 or 5 megabits. And they've got 23 megabits to play with. And then you look at some of the others and they're under 1 meg or a meg, and you wouldn't know the difference. Like the racing one is one that's very, very low. And you get some very funny...
I think people are looking at the horse whiskers or something like that. But
No. Bitrate and resolution are independent.
sure, yeah.
So if you've got it just, when you get too much data for the bandwidth that you're running, it then starts to do interesting things. Doesn't generally block.
It depends on the codec.
Yeah, but what it does do, it throws away high frequency information, because it's that's the way that MPEG and H.264 both work. So what happens is you find you've got the horses walking around in the saddling paddock, lovely crisp pictures, and they take them around to the starting gate, still nice. They come out of the starting gate and down they go, down the back straight, at which point all the vertical posts in the fence disappear because they're moving fast, so that's high frequency information. So get rid of it, because the camera is tracking the horses, so they're not moving fast relative to what you're seeing. It's the background. Same thing with football. When they follow the thing, you'll find that the crowd goes in and out of focus. Or when you find with the race coming around, they come around the corner and they come down towards the finishing post in the straight, and the grass has been green mush while they've been going along, and they come along to where they're coming towards you, and suddenly the grass goes boom, and it's got all its data, all the resolution.
With the,
But-
you mentioned the data like betting odds and things, that'll all be encrypted, of course.
No, you can walk into a TAB and watch it, so there's no point. They want everybody to watch it, and they want you to use telephone betting. So if you had that information, appropriate receiver and so on, you could get it. Who wants it anyway?
Run your own information.
Yeah.
Retransmit and fiddle on numbers?
That'd be a bit hard. But anyway, that's the goings on with that. Now, there's different DAB system. The original L band, Eureka, there's band 3, which we've talked about. There's a couple of systems which are used in the States. It's called IBOC, or sometimes you'll hear it as HD radio, and they are evil. The Yanks tried to get us to go that way, and it was the same with television. They have ATSC, and we have PAL, or DVB, which is the European standard, and we went with that. But I spent a significant amount of time running around Australia with a 1 kilowatt transmitter that we kept changing backwards and forwards between DVB and ATSC to do the testing. ATSC is digital, but at the rates that are used for NTSC.
So what's the joke that goes along parallels and not quite the same colour?
Well, the digital one's the same colour.
Well,
The digital one's always the same colour.
yeah. Well, that's more or less right. But no, with NTSC, phase determines colour. They transmit a reference, which is the subcarrier, in burst, and then if you want green, it's so many degrees around. If you want red, it's a different number of degrees around. So if your subcarrier locally in your set is not coincident or synchronous with the station, and you've got a knob which is called hue that you can set it to be right, you look at a picture and you say, okay, well faces should be that colour, and you turn the knob until they're right.
Quick and compare it on
well, there are automatic systems that they brought in towards the end of things, but the whole point is that with DVB, what they do is they transmit rotating the phase by 180 degrees on the red channel, and then they delay either red or blue, like the U or V signals, and then when you look at them, if it's got a 30-degree phase error, they cancel, because it's plus and minus 30 degrees on alternate lines. So that's why they call it PAL, phased alternate line. So it means that it desaturates, so the colour becomes less intense, but it's still the right colour. A face looks like a face, whereas in ATSC it doesn't. There's still issues with ATSC because ATSC is a single carrier system, so it is very critical about things like multipath and things like that, whereas the OFDM that's used, COFDM that's used in the DVB system is not. IBOC was their attempt at producing digital radio. So it will work on AM or FM, but the issue with it is interference between adjacent stations. And it also uses a lot more bandwidth. Like if you have an FM station, the maximum bandwidth that you're going to use is 800 kilohertz. And it fills that 800 kilohertz up with, and they use 400 kilohertz offsets for stations in nearby areas. So what happens is if you've got 800 kilohertz of digital being pumped out, it does awful nasty things to the FM station next door to you. And AM, when you've got propagation at night on AM, it's even worse. So there's almost nobody using AM IBOC. They're using the FM, but you've got to transmit two carriers. One is the digital carrier, which is running at 1/10 of the power of the FM carrier. And so when you start looking at how you do that, you either waste a hell of a lot of power, because to get a signal which is 1/10 of the power, you either have to have a 10 dB coupler, so you actually lose 9/10 of that digital power into a load, or alternatively you've got to have an antenna which has got two sets of dipoles on it, one for the FM and one for the IBOC. So it's got serious problems. DRM is probably what we should be using. DRM is an OFDM signal which is very narrow bandwidth. It was designed by a consortium, but the French basically were the people, Thomson CSF were the people who really, and Fraunhofer were the people who came up with it. It's got all the advantages, but it works on HF, it works perfectly. But there's not many places actually using it. The ABC has been running it out of Townsville, but I think that's being switched off. Radio New Zealand has been running it. And there was a big thing about India going DRM. They bought DRM capable transmitters, and it'll work on shortwave extremely well, but they're not running it at the moment. The main problem is there's no receivers, because, or there are, but receivers are very expensive, because they just scale.
No volume.
There's no volume. And everybody was... There were two receivers that were available. One was called a Himalaya, which came out of Hong Kong, but they're not available anymore. And there was one which came out of the UK, which used a radioscope module, which was capable of doing DRM, it was capable of doing DAB, it was capable of doing shortwave, it was capable of doing broadcast and do FM in the one module. But unfortunately, radioscope went broke. So there were people like Bush and Morphy Richards and so on were producing radios using that module. So if you have one of those or get one of those, they're a brilliant thing to have, except they don't receive anything here now because we're using a different compression method. I mean, they're beautiful on DRM, they're beautiful on the HF and broadcast bands and FM, but DAB doesn't work because there's no demodulator in there for AAC. So they're the various systems which are available, but the thing is, if you want to use DAB or DAB+, until you get a situation where you can drive from Sydney to Melbourne and have DAB all the way, there's not a lot of incentive for the auto manufacturers to put DAB in.
It'd be nice if I could drive from Manly-Warringah to Terry Hills. I've got a DAB plus my new car, and it came out 3 times tonight because I knew the seat was going on. I may have paid attention, and the last one was right at the traffic light at the top of the hill.
No, it should be all right there.
No, go out there.
Oh,
Not very good with antennas.
maybe something's wrong with the repeater up there. I'll have that checked. There's two repeaters. One of them is up in Coleroy Plateau, and the other one is
On the water tower?
yeah. Oh well, I don't think it's on the water tower anymore, but it was on the water tower.
Maybe that's why it's not working.
Yeah.
It does all the ensemble?
Yes, yeah.
Okay. Because I get some DAB through Oakhurst Parkway much better than others.
You don't get the ABC very well.
No, I'm not listening to ABC.
Yeah, well, you won't get the ABC
Yeah,
very
yeah.
well.
Yeah.
I'll talk about that in a little while. That's even funnier.
I think Buddha works and the 80s and 90s stations don't.
They should all be the same.
Big difference between them for some reason.
Anyway, you can only go, you've got to have vertical polarisation on band 3 for radio because you want it to be different to the TV because of isolation, yeah. So that's why here in Sydney they had to change all the panels on the 710 tower to dual polarity panels. So the TV is horizontal and the DAB is vertical. Cost them a squillion.
Oh, that's the top part of the mast.
Yeah.
Yeah, right.
Yeah.
They're all dual polarisation.
Well, there's also UHF up there now.
Yeah, I think the UHF's right at the top, isn't it?
It's right at the top,
The
yeah.
UHF panel's right at the top.
And that's basically, that's not being used anymore. There's nothing on it.
UHF?
Hmm.
What's the
Was
digital TV?
SBS.
Digital TV?
Yeah. Yes, that's on Channel 7 now.
All VHF.
It's all VHF?
Yeah.
Okay.
It used to be Channel 34. And so it's just sitting up there with nothing on it. Yeah.
Oh, we could put something on it.
Yeah, you put a beautiful repeater on 70 centimetres up there, let me tell you. Anyway, to be able to go Sydney to Melbourne and so on, you would have to have a string of repeaters down the highway, and there's legislative and political problems that it can't happen because each area going down, so when you say you've got Sydney area, you've got Mittagong, you've got Goulburn, you've got Yass, you've got Canberra, you've got the various ones going down south. Radio stations are very, very much into being quite nasty about the adjacent radio station getting into their area, so that nobody gets commercials from the other area. And so you can't just take the Sydney program and keep replicating it all the way down the highway, because when you get to Mittagong, Nowra, who actually have got the repeater up on Mittagong, say, no, you're getting into our, it's a problem. You've got Sydney ones, we want to be in the mucks, and the Sydney stations say, no way is Nowra going to get into Sydney. So it's just not going to happen. The ABC, it could happen because the ABC run the same program and SBS run the same program everywhere. So they could do it with ABC, but the commercial stations are saying, no, we've got to be able to do our local thing with local commercial stations. So while it sits like that, nothing's going to happen. They want to go with local DAB, and so the next ones that will be done, one that's going to have to be done and very soon, is Gold Coast, which won't have Brisbane on it. It'll be their own number of stations on the Gold Coast because of the games up there next year. So that's why they've got to have it here. The next one then will probably be Hobart. Hobart were destined to get it in the first group, and the stations down there said, we can't afford it. Because each of the capital cities, the 5 capital cities that has got DAB plus at the moment, they have a joint venture company which all of the stations are shareholders in, and they all share the cost. And that meant Hobart, with a limited number of stations, just couldn't afford the cost of putting in the gear on Mount Wellington to be able to have their own local service. DRM, you could convert the half dozen or so 50 kilowatt stations that the ABC run out in the country areas and cover all of Australia with DRM, but not, again, you would have one program covering everywhere, so there's issues with that as well from a political point of view. So that's the goings on with the various... Using a lower MF, yeah. Broadcast band.
Right. Oh, really? Right.
Yeah. The encoding that's used, the Musicam encoding, the original one, was the first one that some people came up with. I'll go through this fairly quickly. Most of the MPEG systems work the same way, and it's tricking your ears. What happens is, if I've got a 1 kilohertz tone, that's the threshold of hearing of the ear. So normally, if that is a program that's running there, and it's down, getting towards the bottom of the threshold, but this 1 kilohertz tone is obviously louder. So if you've got a 1 kilohertz tone, it will mask this one so you don't hear it, because your ear only hears the louder of the various signals that are there. So if you've got 4 or 5 signals that are in here and you've got one big tone, that's the main thing you're going to hear. So what you can do is say, well, the ear isn't going to hear this, so we won't bother encoding it. So you only encode what you need to be able to encode.
There's not a harmonic structure in that masking. There's not a harmonic, like 1 kilohertz doesn't mask 2 kilohertz, it masks a band like that.
Yeah. It's a level thing.
I thought it would be more harmonic.
No, it's not related to harmonics, but that is something that happens with AAC. What they can do is they can use the low frequencies where the ear is less responsive, and from that they synthesise high frequency information which is in phase coherence. So you listen to something and it sounds very good, but the actual high frequencies are not the original ones that were there. So it's just tricking the ear, which is mostly the thing. Now, if you they use up to 384 kilobits with Musicam, which is a ridiculous amount of spectrum to be using, rather than the 32s and the 48s that you were looking at on that other thing.
I prefer to listen to music at 384, but...
Oh yeah, oh yeah. Well, AAC at 384.
It's pretty rough, even with AAC.
Oh yeah.
48's a bit rough.
Yeah, 48, 41 or 48's the typical ones for sampling. And so if you've got 96 kilobits AAC-HE at 48 kilohertz, it sounds real nice.
98 would be right, 96.
96. That's typically what's up on the satellite for distribution.
But all of them, even the
Yeah.
Okay.
It's put up there at that because it's going to be retransmitted, so it only comes down to be...
Well, most of the digital ones are 48 kilobit.
Yes.
So they're getting down samples before broadcast underground, or are they coming?
No, it's separate encoding.
They're coming
Like
down-
say for 2SMs,
Yeah.
the uplink in there is running at 96 on everything.
Okay. So
Because it's going to the satellite and coming down again, so it comes out as analog or comes out as AES, as like digital, but it comes out and it turns back, if you want to, into analog to feed an FM transmitter.
Yeah, okay.
So
they're coming down at 96.
they all come down at that, or most of them do anyway.
Yeah. That's
So it's unrelated as to what the transmissions rate is as to what it's going to be for distribution.
So like the
So 147, Eureka 147, the BBC set up a huge network, and as I said, DAB Plus uses exactly the same transmission parameters as it did in the original system in the UK. So what you've got basically in a simple DAB system, audio encoder goes into a multiplexer. The data goes in separately. That's what I was saying about that the two rates are not the same. That goes into a transmission multiplexer, which has this thing called FIC, which is the fast information channel. And what it's got is it tells you how many services are on this multiplex, what they are, what the rates are that it's running. It's all the information the receiver needs to be able to find the services to decode them. Goes into an OFDM modulator at the transmitter and out we go, and it's like about it's 1.6 actually on there. So that's what there is in the system. The only difference is that is AAC plus instead of the original Musicam or MPEG layer 1, MPEG 1 layer 2, which is the first MPEG system.
So the TV channels are sticking the program guidance in as a data channel then, are they?
I'm sorry?
The TV channels are sticking, when they're doing digital TV, they're using a digital channel, a data channel for program guide type information, are they?
No, it's all part of the same signal. There's one stream.
The channels are quite different in how frequently they seem to update stuff.
Yeah, well, it's up to there are limits as to what they can do, but it says like the certain tables, internal in the TV transmission is what they call the service tables, and there's one called PAT or a program association table, and there's one stream of 23 megabits, and that's it. So in amongst there's a packet ID, which is 0, which is the PAT or the program association table, and it tells you where the PMTs are for each service. So it says the video or this service uses this PMT on this packet ID or PID. Then if you go to that PMT, it then lists all the individual video and audio services or data or anything that's in there, but it's all in the stream. And the tables are a bit like a Russian, doll thing where there's one on top of the other. They're all, one tells you where to find the next one. And so where Channel 7 or somebody is running half a dozen services, there's one PAT, there's half a dozen PMTs, and there might be 20 PIDs for various teletext, audio, what's next, all that sort of stuff. So it's a tree, a hierarchical tree. But in DAB, the fast information channel has got, effectively, it's what the tables are in TV. The synchronisation channel basically just says to the receiver, sync to this. So when you've got single frequency network. That's what it uses. The FIC gives you the descriptions. The main service channel's got all the audio in it. So that's what happens in coding in DAB. So we've got here, again, the same thing. It's one stream. You've got synchronisation, fast information, and then you've got the various services, and that's the audio for each one. And it's told how to decode each of those from the FIC. Now, there's a lot of FEC in there, just to minimise the error rate on the data. So it's actually transmitting about 3 megabits. There's about 2.3 megabits, which is the main service channel, but the actual encoding and so on, the useful, is about 1.6 to 1.7. So it's about half of what's actually transmitted, but that's typical for most digital signals. They use COFDM, which is a very efficient, spectrum efficient thing with a lot of carriers. In this one they use 1536 typically in DAB, and it either uses something like 2000 or 7000 or 6000 in television in DVB, and DRM only uses about 250, so that's why it's a very narrow band system. But this is saying the data is distributed amongst all the carriers with about 1.5 meg of the spectrum. The symbol rate on any individual carrier is very low because you've got 2,000 carriers taking that information. The symbol rate is very, very low on each one. And the stream is put on multiple carriers and spread across the whole bandwidth that's available. So it means a longer symbol period, giving protection against multipath echoes, where it sees a signal direct from the transmitter, plus a number of delayed signals due to reflections. And by deliberately repeating part of each symbol during the guard interval, COFDM provides enhanced tolerance against multipath. So that's what we were referring to earlier. It also then makes single frequency networks a possibility, where man-made multipath is deliberately created by having all the transmitters in the network transmitting the same signal on the same frequency, something that would not have been possible with existing analogue systems, obviously.
Actually, they're going to be timed, quite.
They're timed, to be exact, by GPS. And so all of the repeaters are... Mm-hmm.
Right.
Oh, yeah.
Yeah. So nanosecond level timing.
Yes, yes. Not only that, when you transmit the signal from the multiplex that's been created down at the donor station, the original station, you can put in extra signals in there that it's like what would be an MIP or multiplex information channel, which is put in there, and it gives the timing for each repeater. So where you've got a single frequency network, it says the one that's up at Newport, we need to time it so many nanoseconds or microseconds from the original signal to make it so that it's not cancelling, or it can make it so it cancels out to C but it doesn't cancel. Like one of the repeaters is up at Winmalee, which is up on the Blue Mountains, and that had to be timed so that in Western Sydney what was coming directly from Chatswood was in time with what was coming back down from there. So we had to put a microwave link in to feed that one because it was just outside the range of what you could do with a single frequency network on-channel repeater. So there's a microwave link goes up to Winmalee from over on the tower at Chatswood. And then you can time it, so you can say, the reason that was done was if you didn't do that, it'd still work, except a lot of the area around Glenorrhea and up around Dural would have been not a mush zone, but it wouldn't have worked very well there. So it's been timed to shift that up towards Wiseman Ferry in places where it doesn't really matter. That's what the signal looks like, the bandwidth. That's actually showing it at a UHF frequency because that was convenient to do it actually rather than the up at Hornsby where we were building these. We're down in the gully and the signal that comes in there, it works fine. You can have the repeater running and everything's fine except it ain't pretty. It's got all sorts of bumps and things in it, I'll show. So anyway, L-band, 1500 megs, too high. 10 or more sites would be needed around Sydney, and that's been proven by the testing that's been done. So by going to band 3, comes down to about 5 sites. The band 3 version is okay over in Europe, where they don't have the same sort of situations as we've got here. The other thing is they can run as many transmitters as they like without the political problem, because mostly over there it's the Swiss Broadcasting Network or the French network or somebody like that. They use the same frequencies, they use the same program countrywide. So they don't have the issues that we have here with local commercials. It's possible to cover the greater part of Sydney with the transmission just coming out of the Artarmon Tower. There's a 3 kilowatt transmitter, 50 kilowatts out of the antenna. To minimise the interference to adjacent channels, and remember this was put in and was working when analogue TV was still there. And the thing was that you had to minimise particularly Channel 9's stereo sound carrier, which is right at the top of the analogue spectrum, and the digital spectrum from this goes right down. So it was a problem. It's the same thing where they tried to put digital analogue to digital adjacent to analogue in TV. The other thing is there's a practical polarisation difference of about 20 dB between the horizontal and vertical, and it's very desirable to have vertical for receiving it in cars. Yeah. Much, if it's 20 dB down, it's a hell of a lot. Then to prevent interference with TV, you have to have the transmissions coming from a common point. You can't go and shove up a radio repeater over at Balcombe Hills when you're transmitting the TV from North Sydney, because obviously, due to distance, the signal on TV is way down compared to a 1 kilowatt repeater sitting in your backyard. So they've got to use common sites, or relatively common sites. So that was another design thing. Over in Europe, they've got the whole thing, the whole band. In Australia, we had 9A. Then they couldn't move channel 10 up, because if you had analogue channel 10 and you shifted it up 1 meg to make 9A a 7 meg signal, it would have been enough that you wouldn't even get a signal on an analogue TV. You'd have to reach in it. So channel 10 rather heavily said, no, we're not going to do that. We don't want it to happen. When analogue was turned off, then you can do what you like. So 9A is now a full 7 meg channel. So the frequencies on the TV channels above that, they're different. They're a meg up from what they originally were. So we had channel 10, channel 9, and we've got 3 muxes in there, 1.5 meg on each one. They're 1.712 megs apart. That drawing is one of the ones out of the report that we sent, and what was used to promote it when the original system was suggested. IBOC, we won't do much about. That's the FM signal. we have digital on either side of it. And this is what, like if you've got another analogue signal here for your adjacent area, it just wipes it out. So you get this horrible digital noise on the FM in the adjacent areas, so it's horrible. DRM, as I said, very nice system if we could only get receivers for it. It's less than 20 kilohertz, the number of carriers, maximum of 460, typically 300, 200, 300. They've only recently approved DRM up to 120 megs. That's DRM plus. So the coding method is the same. So what it means is you now have band 2, which is where channel 2 used to be, and channel 0 and all those. You could put DRM in there. So if you've got to get receivers, and they're going to make receivers, just as easy to make it for 50 or 60 megs than it is to have it as any other frequency. So that's a possibility for the future. But CRA, if I go down, stand at Central Station, and they're up in Sussex, in Bow Street, and say DRM, somebody will come down with a machete in about 30 seconds. They hate it because they've been promoting DAB so much. They don't want to know about DRM. The government is a little more realistic about it, and they're looking into DRM. So, watch.
Software decoders for these things, like the RTL, FDR people are playing with building decoders.
Oh yeah, software decoding, yeah. Well, this is the thing. Like, I mean, you've always been able to get decoders from for DRM, and basically that's pretty much how they work. Well, it tunes in with a down converter of some sort, and you feed it, and you feed it into a.
Taking protected or is it?
No.
I know that was free. DRM was free. But
yeah. But you feed it into a sound card at around 16 kilohertz, and you feed the DRM signal in, and you can decode it in the computer, and it works beautifully. That's just a drawing of the head end for the ABC. The way that they wanted to do it a bit differently to this, and this was my idea for it, and what eventually happened, they wanted to put a huge switching matrix up ahead of this so they could select programs in. And Radioscope made this kit box which went in there, and basically what it does is it takes the output of a mux, so they feed 20 programs, or it's 18 programs actually were going in between SBS and ABC. It goes into a mux, and so at this point we've got a 1.6 meg mux. We take that, and this thing is a thing which pulls the mux apart again into its individual services, and it then comes down. So what you can do is the Melbourne one takes the Melbourne stations in, and it produces a mux. But the Sydney ones, the national ones, just go in straight into the Melbourne one, Adelaide, Perth, Hobart, Brisbane, and so on, so that you don't have to feed local muxes down in Melbourne or down in Adelaide or whatever. All they do is they feed the mux output down there, and they change all of the signals that are going into that mux. It's all IP, and it's done here in Sydney. So in the ABC and in Harris Street, there's a couple of racks full of these things. And so what it does, if you have like Radio National, you only need to encode it once, because it's the same encode going through the various muxes, and it just comes out on all the various ones. So they have a 2 meg path going across to Perth, which takes the 1.6 megs, cheap. If you did it any other way, you'd be feeding Radio National, News Radio, and so on. Then you just add your local one in over there, but you'd be feeding a hell of a lot more bandwidth over to Perth to do it. So they looked at this and only saved them $800,000 by doing it this way over the other way of doing it. So they were real keen on that. So that's the way it was designed, that's the way it's still working. Infill repeaters, these are the repeaters that I designed and what we built. They're basically, that's just a picture of one of them. They're a gap filler for filling in areas where the coverage is not as good as it might be. Single 42 RU rack, it works on single phase 32 amps or two 16 amp power points. The maximum power is 900 watts average, so it's RMS power, it's not PEP or anything, it's real power. And all three ensembles go through that. So that's the device that we did. It uses a passive filter splitter on the input from the antenna so that it splits it into three individual processors. The three processors do echo suppression on each mux because the muxes aren't synchronous in power or in the makeup of the carriers. So there's three separate ones. Then we combine them again passively and then feed it into the power amplifier, which is a 1.2 kilowatt amplifier. The adaptive driver is this thing here. So what we've got is the input comes into this box, which is made by a crowd called Teamcast over in France. And it's a very clever box using DSPs and up and down converters and everything else. Dual power supplies, and this is the drive amplifier. So that box, there's three of those, one for each mux. There's a clipper which is internal in that box, and it limits the peak to average signal to about 13 dB. If you don't do that, you blow up amplifiers, which we found out the hard way. What happens is, if you've got 2,000 carriers, or 200 carriers, doesn't matter, with OFDM, and each one is phase modulated with the data, statistically it is possible to get all the carriers in phase at the same time. And when that happens, you get approximately 10 dB, or 13 is as far as you can go, times when they're cancelling.
Yep.
So the actual peak output power varies instantaneously and dramatically. So you have to clip it so that it can never get above 13 dB.
Sort of like recording a symphony orchestra on a CD, isn't it? Sort of like recording a symphony orchestra on a CD. All those instruments hit their peaks at the same time.
Yeah, well,
but you're not going to hear it on a CD.
yeah, but that's also the psychoacoustical thing comes into that, which it doesn't with this. It's called blow up the power output at a stage.
Yeah.
When you have, you combine three different ensembles together, the same thing happens. Even though you've got a whole lot of carriers being limited to 13 dB in that box, when you take three boxes, then it's statistically possible for them all to come together at once, and so you've got three lots of them, so you've got to go back to clipping to 13 dB. So we then have a clipper after the combined, and that's the power amplifier. Lovely. They're a TV power amplifier for band 3. It's exactly what you'd use for DVD. You can get 1250 watts out of it in TV. It's made by a crowd called ABE in Italy. They're ultra reliable, lovely amplifier.
Ian, there's been a bunch of modules that I believe came from Channel 9 floating around at Durham and places frequently. Can you
Oh.
talk about those?
Yeah. A TV transmitter, a lot of the ones like the high power ones, the analogue transmitters used anything up to 20 kilowatts, and they had 50 kilowatts ERP, but there are a whole lot of modules. And so what happened was they then combined the output of those modules, so you get a module which is relatively small, it's got its own power supply, but they're not made to go to 2 metres, or some of the ones that were made for UHF are okay, but some of the ones that have been around came from down the Riverina. They were Channel 5A down there, RTN. So one of the guys from Shepparton got all the modules out of there, and he's been handing them out through the clubs down in Melbourne. And then people have bought them and then decided to resell them, so there's a few of them floating around. But a standard module is not a lot of use. It's got lovely transistors in it, but the printed lines on the circuit boards, bloody hard to change in frequency, because they're 50 ohms, they're a certain width, they're a certain length, and you've got to do a lot of messing around to make it 50 ohms at a different frequency.
Kevin Jardine over at Haddock tested one of those modules, not full power, but...
Well, you won't get full power. I mean,
no,
yes.
It doesn't look, I mean, you've got the VNAs and stuff, it doesn't look bad at 2 metres.
Oh, yeah, but I mean, its efficiency is probably 30% of what it was in the original. They're
problem with power, though.
Oh, yes, yeah, you know, quite typically you'll get 400, 600 watts out of some of them. They're a nice thing. These, what they've got in there is actually 4 modules with 2 dual transistors in each one. So it's done that way with the combining so that it cancels second harmonic and gives you, like, realistically you can have this 13 dB. 13 dB is a lot. If you've got something which is running nominally 400 or 500 watts, you're now talking 5 kilowatts at 10 dB up. So it depends on the design of the thing, how it is and what the limiting does, but we've found those to be totally reliable using, we get, they've got to be backed off from the 1250 watts that they normally do, because you've got 3 carriers going through there, so you've got intermods that come up if you try and run them all at full power. So anyway, we can get 900 watts without any problem on the 3 ensembles. Now, we're talking about the ABC not being quite as good as on the repeaters. It'd be very quick from here.
Don't listen to him. I'm enjoying it.
The ABC haven't been paying their bill because they cry poor that the government don't give them the money. So they're a member of the joint venture, but they're not paying the fees that they're supposed to. Politically, CRA has got to repeat. If they put a repeater in, it's got to repeat the ABC. And if they're not paying their share of it, they said, okay, we will transmit it 20 dB down. So each of these processors for the ABC in the 5 stations or 6 stations have been put in, they've all got a 20 dB pad on the ABC marks.
This is about the phase and cancel?
No, just cancel it out. It's only low level. It's like you're talking 0 dBm at that point. So until the ABC gets some money from the government and they turn the wick up, you're not going to do very well. They're there, they're being transmitted, but that's the story. Control is done through a remote control system. It's all done on 4G. To control them remotely, we've got GUIs like this that all work. They talk to the Teamcast module, which gives you all the information on it remotely. One of the things which is absolutely essential is earthing. when you've got things with an antenna stuck way up in the air out in the middle of nowhere at Winmalee or somewhere.
Lightning rod.
You got it. So we run 50mm cable from brass studs on the thing.
And 3 nuts.
And 3 nuts on it, or 2 of them, because one of them that holds it. But all of the cables inside are colour-coded for each, so, you know, ensemble 1, ensemble 2, ensemble 3, and power amp. So the control talks, and that's what the whole rack looks like. It's got a UPS power amp, control system. The 4 modules that go in are the individual ones for each. That happens to be a 2 ensemble one, because not all the capital cities are running through ensembles. Splitter and so on, that's the 4G modem, and that's the filters. I won't go into any more details other than the fact to say that the echo cancellation, what happens is if you transmit a signal out of your repeater, there's a finite delay to get from the output of the transmitter up to the antenna, which is typically up high. The transmit antenna is, you may have the transmit one up high and you've got the receive one down low. Doesn't really matter. There's a practical difference between the two. Typically 70, 80 dB, which is not enough to really run 900 watts. So this box, basically, on a digital basis, looks at the incoming signal from the originating station, and it takes a digital snapshot of it, and then it keeps comparing that with what's coming back in time. And when it comes to that same digital snapshot, be it nanoseconds or microseconds later, be it from a reflection coming in from somewhere, like it is here, where the reflection is a long way in time rather than just the local one, it says, I recognise you, that came in a while ago, inverts it and adds it so it cancels your own signal coming back. And doing that, it gives you a capability, or a gain margin, as it's called, of around 10 to 12 dB. So the originating signal can be 12 dB weaker than your own signal coming back on the repeater. And so it just cancels it out.
So does that work still well fast enough when you're mobile? Just driving?
It doesn't matter, this is only at the fixed repeater point.
Oh, okay.
Yeah.
Is that
So
tracking in real time? So if somebody puts up a brick wall?
Yeah, whatever you do, it's realistic, yeah. So that's what they call gain margin. It's basically the gain that you can get over the thing. That's what the filters had to do. They had to have a big notch here for channel 9 sound carrier and typical one on the other side. But the filter is less than 1 dB loss in band, and you're talking lots of, 35, 40 dB down here. That's the output of the filter, or sweeping the filter. So there's the original signal. There's some activity can still get through up and around the 500 megs, but at 400, 450 where we're interested, it's 110 dB down. And so they're designed to be very friendly filters. There's 2 of them in series because you can't get that performance off a single figure filter. And believe me, they're a bugger to tune.
So they're built here? They're built here in Sydney? The filters were built here?
No, they're built in Italy.
Okay.
But we've had to change some around to make them work on different frequencies, like they use channel 10 in Canberra, for instance. But you can see there, that's the thing, you're talking 0.9 of a dB or so across the thing, and then it comes down. That's off the Roden Swartz. That's a practical plot, and better than 20 dB return loss at all from the signal. So that, and as I said, that doesn't look pretty, even the original signals. because you don't get a nice square signal when it's off an antenna at Hornsby. But what we first tried was, instead of using 3 1.6 meg ones, was a single 6 meg one. So that ACO was using 5.8, or 5 megs of the thing, 6 megs, it should work. This is because it picks up noise out of band and tries to echo correct the noise. And these are like 17 to 20 dB higher, at which point your amplifier goes bang. So we learnt that the hard way. That's the active combiner for combining the signals. Basically, it takes the 3 coming in, splits them. This is the limiter, and this is a power amplifier to get the power to drive the amplifiers. So they're all combined again, and they all go out on one signal. But that was just the prototype one. We now build them into a box like this. Thank you.
A question, you talked about transmitting DAB with vertical for cars.
Yeah.
That's absolutely fine. Well, I'm old enough, I remember when FM broadcasting was first introduced here, and there was some discussion about that. I understood they ended up transmitting the FM with circular polarisation. So vertical for the cars, but also horizontal for people at home where zip, bit of 300 ohm ribbon, who tend to be horizontally polarised.
Well, there's a lot of the FM transmissions are all done a circular or mixed polarisation.
Yeah.
And the reason is that it's for multipath. If you've got a signal which is circular, it's a reflection is going to be the other way around. If you take vertical going and it bounces back, it's horizontal.
No, yeah, but also, I mean, it does make sense. That's what I heard at the time. It made sense then. It still makes sense now that if you want to have a DAB receiver at home, you can just take a strip from your TV antenna and...
Look, you can do it, but it's going to be 20 dB down,
yeah,
that's all.
Does the reflection make the flop light go in flop light, does it?
Yep, the circular, yeah.
Mm-hmm. Yeah. And with mixed polarisation, they're not necessarily out of phase. Like normally you'd take the thing and shift it 90 degrees. You don't have to do that. You just use the horizontal and the vertical components of it, but not 90 degrees between them as you would in true circular polarisation. But if you receive circular polarisation on a linear antenna, it's 3 dB down. And that's the only difference.
3 dB to 20 dB.
Absolutely, yeah. The only other thing I didn't mention was when we build these boxes, we're going to mask the painting so that we have the contact point there, and the same thing on the lid. It's got to be unpainted inside. And
You're lucky you got away with that fewer screws, actually.
yeah, there's a heap of them. There's 25 screws or so. And then the other thing is these ears, where it goes into the rack, the mounting strips that we use for the rack, the ones with the captive nuts, they're all bare. They're not, well, they're not bare, but they're passivated. They're not painted. So very particular about the earthing.
So Ian, you're moving to Wellington?
Yes.
Right? Does that mean you retired?